All right, so here what we have in front of us is the entire real number system. So the real number system, let's start at the smallest set of numbers and then expand from there. So the smallest set, the most basic set, is called natural numbers or counting numbers. And those are the ones that you can count on your fingers. So 1, 2, 3, 4, up into infinity. So that's the natural or the counting numbers. Then if we pull back, if we expand, then we'll see that we also have a circle that surrounds the natural numbers. And that circle would be whole numbers. And whole numbers are all of the natural numbers, including an additional number 0. So whole numbers, an example, would be 0, 1, 2, 3, up into infinity. So whole numbers encompass natural numbers plus 0. Integers, we're broadening out yet again. Integers include counting numbers, natural numbers, and includes whole numbers. So it includes 0. And integers also include negative numbers, or negative numbers that you know are whole in nature, no decimals or fractions yet. So integers can be 0, 1, 2, 3, but it also could be -1, -2, -3. So it goes up to infinity and down to negative infinity integers. So integers include everything inside plus these negative numbers. Then rational numbers, we are going to pull out even further. Rational numbers include everything in these smaller circles plus our fractions and decimals. Decimals that either terminate, like this, 0.5, or decimals that don't terminate but repeat. So like 0.23232323, okay? And of course, everything else that's inside these smaller circles count as rational numbers as well. So like the number 5, that's a rational number. -8, that's a rational number. Remember, any number that you can rewrite in fraction form or ratio is considered a rational number. So 5 is a rational number because you could write it as a ratio of, or a fraction, 5 over 1. -8 could be written as -8 over 1. So remember, everything in these smaller circles are included in the larger set of rational numbers. Now, we're going to make a distinction between rational numbers and irrational numbers. So that's why I drew a line right here, okay? So irrational numbers are something completely different. Irrational numbers do not include anything over here. That's why I put a line here. And irrational numbers are all over here. And irrational numbers are decimals that go on forever, but they never repeat. So that's what an irrational number is. If it has a decimal that goes on forever and there's no pattern to it, it doesn't repeat. So for instance, pi. Pi is probably one of the most famous irrational numbers. It's 3.14 ... It goes on forever, but it never repeats. It doesn't have a pattern to it. These are completely just random numbers in decimal places, and it goes on forever. So that's why pi is irrational. You cannot write pi as a fraction. You can approximate it as a fraction, but only roughly. Only roughly. You cannot put pi in fraction form exactly. There's lots of irrational numbers. Radical 2, the square root of 2 is irrational. Just type 2 into your calculator, hit the square root sign, and you'll see that the decimal goes on forever and never repeats. So those are irrational numbers. And if you count our irrational numbers and our rational numbers and all the subsets of rational numbers, you will have the entire real number system, okay? So that's a good, hopefully, overview of what we've been talking about in this unit. And later on, we will talk about the non-real number system, which is a completely separate whiteboard even than this. And the non-real numbers we call imaginary numbers, but that will take an entire board just for itself, which we'll talk about later. Thanks.